Hi all. In last video, we discussed about the definition of sets, different types of sets, and different representation of sets and examples. Today, in this video, we will discuss about different types of sets. So these are some of the different types of sets. Empty sets, finite sets, and infinite sets, equal sets, subsets, power sets, universal sets. So, we will discuss each of these one by one. First one, the empty set. Consider this set. The set A equal to set of all x such that x is a student of class 11 presently studying in a school. Assume that there exist 21 students which studying in class 11 in a school. Then the set A contains that 21 students. But in case of B, set of all x such that x is a student presently studying in both classes 10 and 11. Is there exist any student who is studying in both 10 and 11? No. So, B contains how many elements? No. B contains 0 elements or B contains no elements. Here in C, set of all x such that 1 less than x less than 2 and x is a natural numbers. That is, C contains all elements, a natural number which lies between 1 and 2. Is there exist any natural number which lies between 1 and 2? No. So, C contains no elements. Similarly, D. Set of all x such that x square minus 2 equal to 0 and x is a rational number. That is, x is the solution of this quadratic equation and x should be a rational number. What are the solution of this quadratic equation x square minus 2 equal to 0? X equal to plus or minus root 2. But root 2 is not a rational number. That is, there exists no rational number which is the solution of this quadratic equation. So, D contains no elements. Here, E, set of all x such that x is an even prime number greater than 2. There exists no even prime number other than 2. So, E is also contains no elements. These sets are called empty sets. That is, the number of elements in these sets is 0. The definition of empty set is a set which does not contain any element is called the empty set or the null set or the void set. That is, the empty set contains no elements. Finite and infinite set. A set which is empty or contains of a definite number of elements is called a finite. Otherwise, that set is called infinite set. That is, finite set contains finite number of elements and infinite set contains infinite number of elements. So, these are some examples. Let W be the set of the days of the week. What are the days of the week? Sunday, Monday, Tuesday, etc. Saturday. So W contains 7 elements. So W is a finite set. Let S be the set of all solution of the quadratic equation x square minus 16 equal to 0. Then what are the elements in S? S equal to plus or minus 4. Plus or minus 4 is the solution of this quadratic equation. So S equal to plus or minus 4. That is, S contains exactly 2 elements. So, S is also finite. But, let G be the set of points on a line. How many points are there in a line? Infinite. That is, G contains infinite number of elements. So, G is called an infinite set. Here, what about this set? Is it a finite or an infinite set? The set of all x such that x is in n, that is x is a natural number and also x is a solution of this equation. So this set contains the elements 1 and 2 because 1 and 2 are the solution of this quadratic equation. So this set is the set contains the elements 1 and 2. There exist two elements, so it is finite. So this set is a finite set. Here, the second set is set for x such that x is a natural number and x is the solution of this quadratic equation. What are the solution of this quadratic equation? Plus or minus 2. But minus 2 is not a natural number. So 2 is the only element in the set. So this set is also finite. Here, set for x such that x is a natural number and x is the solution of this equation. What is the solution of this linear equation? 2x minus 1 equal to 0, 2x equal to 1 or x equal to 1 by 2. But 1 by 2 is not a natural number. So the third set is an empty set. That is, empty set is also a finite set. So the third set is also a finite set. What about the fourth set? Set for x such that x is a natural number and x is a prime. How many prime numbers are there in the world? Infinite numbers. And these all prime numbers are also natural numbers. So this set is an infinite set. Next, set for x such that x is a natural number and x is odd. What are the odd natural numbers? 1, 3, 5, 7, 9, etc. Is it a finite set? No, infinite. So the last set is also an infinite set. So here the first three contains finite number of elements. So these sets are finite set. But these last two contains infinite number of elements. We cannot count how many elements are there in this set. So these two are infinite set. Now we can discuss about equal sets. Two sets A and B are said to be equal if they have exactly the same elements and we write A equal to B. Otherwise, the sets are said to be unequal and we write A not equal to B. Consider this example. A equal to 1, 2, 3, 4. B equal to 3, 1, 4, 2. The order is different, but A and B contains the same number of elements. So, A equal to B. Now, in the second set, let A be the set of prime numbers less than 6. So, what are the prime numbers less than 6? 2, 3, 5. Now, let P be the set of prime factors of 30. These 2, 3, 5 are the prime factors of 30. So here A and B contains same elements, same number of elements and exactly the same element 2, 3, 5. So we can say that A equal to B. Now this is a new term, subsets. A set A is said to be a subset of B if every element of A is also an element of B. We can write the definition of subset as follows. This line is read as A subset of B if A belongs to A implies A belongs to B. That is, we say that A is a subset of B if A is a member in the set A, then A should be a member in the set B. Here there exists an example. Let A equal to 1, 2, 3 and B equal to 1, 2, 3, 4. Just look, is every element in A is also present in B? 1 is present in B, 2 is present in B, 3 is also present in B. That is, every element in A is also present in B. Then we can say that A is a subset of B. Now, consider X and Y. Here, X contains the elements B, C. Y contains the elements A, B, C, D. Is every element in X is also present in Y? B present, C also present. So, we can say that X is a subset of Y. Now consider P and Q. P contains the elements 10, 11, 12, 14, 15. Q contains the elements 10, 11, 13, 14, 15, 16. Now 10, 11, 14, 15 are present in Q, but 12 is not present in Q. So we cannot say that P is a subset of Q. We need to say that P is not a subset of Q. Also, Q is not a subset of P. Why? Because 13 is not present in P. So Q is also not subset of P. They are unequal and not subset each other. There exists a not every set A is a subset of itself, because we can say that A is a subset of A. Every element of A is also present in A. So A is a subset of A. Also we can say that P is a subset of P. Q is a subset of Q. So every set A is a subset of itself. Since the empty set phi has no elements, we agree to say that phi is a subset of every set. These are some of more examples. The set of all rational number is a subset of the set of all real numbers. We can write it as Q subset of R. If A is a set of all divisors of 56 and B is a set of all prime divisors of 56, then we can say that B is a subset of A, because every prime divisor of 56 is also a divisor of 56. That is, every element in set B contained in the set A. So we can say that B is a subset of A. Now consider the third example. Let A equal to set contains 1, 3, 5 and B equal to set of all x such that x is an odd natural number less than 6. What are the odd natural number less than 6? 1, 3, 5. All are present in A. So we can say that A subset of B and B subset of A, because 135 is contained in B. Also every element in B is also in A. So we can say that A subset of B and B subset of A. That is, both are equal. Actually both are equal. Next, let A equal to A, E, I, O, U and B equal to A, B, C, D. Then we can say that A is not a subset of B. Why? E is not present in B. I is not present in B. Also U is not present. So A is not a subset of B. What about whether B is subset of A? No. Why? B and D are elements in B, but they are not present in A. So B is not a subset of A. Now we can discuss about power set. This is the definition. The collection of all subsets of A set is called the power set of A. We denote it by P of A. Here is an example. If A equal to set 1, 2, then power set of A. What are the subsets of A? Phi is subset of every set. So phi is in power set. A set itself is a subset of A. So set 1, 2 is present. Also set 1 and set 2 are subsets of A. So the subsets of A are phi, set 1, set 2, set 1, 2. So this is the power set of A. How many elements are there in this power set? 1, 2, 3, 4. 4 elements. So N of P of A. or number of elements in the power set P of A equal to 4. There exists an equation to find the number of elements in the power set of a set A. This is the equation. If A contains m elements, then the power set of A contains 2 raised to m elements. If A contains 5 elements, then its power set contains 2 raised to 5 elements. If A contains 6 elements, then its power set contains 2 raised to 6 elements, like that. Here is the more example. If B is the set AB, then power set of B is empty set, the set itself, and set A, set B. If C equal to 1, 2, 3, then power set of C. These all are subsets of C. So this is the power set of C. Here is one more example. D contains 4 elements. So this power set contains 2 raised to 4, 16 elements. These all are subsets of D. So this is the power set of D. Now we can discuss about universal set. Usually we take a basic set and subsets of that basic set which contains a common property. For example, while studying the system of numbers, we will take the set of all natural numbers and its subsets such as set of all prime numbers, set of all even numbers, set of all odd numbers, etc. So, this basic set is called the universal set. Here, the set of all natural numbers is said to be the universal set. Usually, we denote the universal set by U and subsets by the letters A, B, C, etc. In next video, we will discuss about more examples and more properties of sets and more problems. Now, thank you all.